All right. On your unit circle, you're supposed to have cosine theta, comma, sine theta. And then I had you go ahead and put the tangents out beside it. I told you to do it in a different color when we do our regular circle, the one that we're going to keep, and that kind of thing. But you're supposed to have that information on there. Of course, you know this tangent is the what? Sine over the cosine. Now, on your unit circle also, somewhere at the top, you need to have x squared plus y squared equals 1, so that you know where the circle came from. That's the algebra expression for it. And go ahead at the top beside that, write the mother identity. That's the mother identity because you're going to need it. Okay? And you won't need that today. You won't need that today, but you'll need this. Now, this is what students usually write at the bottom. And we're just going to look at a little thing at the bottom. They usually put this at the bottom. Cosecant theta is the reciprocal of sine theta. Please do not put sine with a -1 above it to mean reciprocal. We can't do that. You have to put cos 1 over sine. Cosecant is the reciprocal of sine. Everybody realize 1 over something is the what? Reciprocal. Did I talk about changing any of the positive and negatives? No, that's perpendicular lines when you do that. I got people wanting to change. No. I'm just saying take the what? Reciprocal. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Now, the reason we wrote these three on the circle is that if you have those three, what's the only thing you got to do in order to find any of these? Take the reciprocal. So there's no use in writing all 6 of them on there like the unit circle that's in the on one of the YouTube channels. Okay. Now, I'm going to give you different types of directions. I'm going to talk about the hardest thing to do first, and then we'll talk about the easier stuff. All right. What I want to do, this is example 1. Example number 1. It will say, write the 6 trig functions values for theta equals 60 degrees. Write the 6 trig function values for theta equals 60 degrees. I'm going to show you how to do it. And you're going to write it just like I write it on the paper when you do it. You're not going to write it in any different order. Now, for some reason, and I don't know why, I always like to do sine theta first. Then I do cosine theta, and then I do tangent theta. I don't write them beside it. I don't write it out that way. I write them in a line, just like that. Is that good? I'll help you. What you got?
No, it's okay.
Oh, okay.
This is in our notebook, right? Or do you want to tell me this?
This is in your notebook. This is actually working the problem.
Okay.
Yeah, no more writing on the unit circle. Now we're actually working the problem using our unit circle. And you list them down there. You don't list them across the page. You look on the unit circle and you tell me what is the sine of 60 degrees. Look on your unit circle. Tell me what's the sine of 60 degrees. Say it. Square root of 3 over 2. That easy. Then you look on your circle. You tell me what the cosine of 60 degrees is. 1/2. Does anyone in here not understand that part right there? If you do, raise your hand because the train, folks, they're filling up the lifeboats on the Titanic, and they're saying we got 1 spot left. Anna Karenina is standing by the train right now. All right. Tangent. Somebody look on their sheet and tell me what the tangent of 60 degrees is. Square root of 3. Now, after you list those, life is super easy. Because right beside those, you write, oh, and you're not supposed to put theta here, you're supposed to put 60 degrees, but if you put theta, sorry, because we're talking about 60 degrees. Okay? Then you write cosecant, 60 degrees, secant, 60 degrees, and cotangent, 60 degrees. And if you cannot look at what, Mr. Evans, be positive. You look right here and you instantly know those. 2 over the square root of 3, 2, and 1 over the square root of 3. Now, I would never rationalize them, but if the answer's in the back of the textbook that you're using or in college, or if the professor tells you to rationalize, what would you do to those once you have the answers? You would do what? Rationalize.
Okay, so was that on like the second part?
I took the reciprocal of that right there.
So that's all that means?
That's it. Cosecant means reciprocal sine. That's what you got written on the bottom of your unit circle, right?
Yes, sir.
You have that written down there?
Yes.
Yeah, cosecant equals 1 over sine, which means what? Reciprocal. Yeah, so all you got to do, if you got this list, you instantly know these. Happy so far? All right, we're going to do example 2. But before I do example 2, I'm going to see if anybody's got a question about this one. Anything? All right, example 2. I want the 6 trig functions. And what you'll find out is in the book, sometimes they ask for all 6, and then sometimes they just ask for 1. My deal is, if you can find all 6, you can find any one that you need, right? You'll never need all 6 of them in a problem. Basically, in calculus, you use sine, secant, and tangent a lot, okay? Sine, secant, and tangent is what you use in all your trig substitution stuff. So that's the 3 that they're pretty big. All right, 6 trig functions for theta are alpha equals 765. Mr. Evans, that's not on my circle. That's the reason I put it up there. I'm showing you what to do when you have numbers that are bigger than 360. I'll tell you how to handle that. Do you realize when you go all the way around the circle, you go 360 degrees? Guess what happens when you go all the way around the circle again? You go what? 360. So anytime you got a number bigger than 360, I'm going to tell you the easy way to do it. Subtract 360 from it. Subtract 360. And when you subtract 360, you get a 405. Oh, we still got a problem. That is still bigger than what? So we're going to subtract off another 360. And we get 45 degrees. So it turns out that the angles 765 and 45 end up in the same place. Because what you do, you went all the way around the circle once, you went all the way around the circle again, and then you went how many more degrees? 45. Now here's where you run into a problem. When you make your list, you must not use the 45. You have to go sine 765, cosine 765, tangent 765. And you write them just like that. You do not write them across the page. Somebody says, he yells at his kids and tells them the same thing multiple times. That's right. I hadn't had my coffee yet. Well, I had 1 cup this morning while I was holding the dog. That's part of my day right there. Life is good every once in a while. Now, you, on your own, make the list of the answers because, let's see, what are the values? Shouldn't call them answers, call them the values for sine. What's the sine value?
1 over square root 2.
What's the cosine value?
1 over square root 2.
What's the tangent value?
1.
1. Now, if you are rationalizing, please don't rationalize these until after you take the reciprocal. If you rationalize on the first steps, you're messing yourself up. Never rationalize till the very end. Then only if you have to. Cosecant, 765 degrees equals just square root of 2. Secant, 765 degrees equals square root of 2. And it turns out that the cotangent of 765 degrees is still equal to 1. Happy? Okay. Now, example 3. Example 3. I want to know the sine of negative 90 degrees, the cosine of negative 90 degrees, and the tangent of negative 90 degrees. Well, that's easy for us because we have negative 90 on our circle, right? Is that cool? Do you realize if you want to, you could add 360 to those and turn them into positive angles and use those? Is that all right? Yeah. Now, here we go. Sine of negative 90, what is it? Tell me. Negative 1. Everybody agree it's negative 1. Look on your unit circle and point at your unit circle where you've got negative 1 written down for me. Point on your unit circle where we're talking. Right there. Right, okay. Yeah. Oh, and if something's wrong on your unit circle, it's a bad day. What's the cosine of negative 90 degrees? 0. And what is the tangent of negative 90 degrees? Undefined. Now, here's why I picked this problem. Okay, cosecant of negative 90 degrees is really easy. The reciprocal of negative 1 is still negative 1. Here you got to be careful. The secant of negative 90 degrees would be 1 over 0. What is 1 over 0? Undefined. Yes, ma'am. Thank you. Undefined. Okay, little note. 0 over 1 equals 0. 1 over 0 is undefined. Remember that. That's algebra. Algebra 1. So, when you look at the tangent is undefined, it turns out the cotangent is not undefined. What is the cotangent? 0. You see, the tangent was 1 over 0, but if you take the reciprocal, you now have what? 0 over 1. That's the one that messes people up. Alright? Now, there's a little section in the book that I like in the assignment I'm going to give you, and it gives you some little true false little bits of information. And all it's going to do is try to get you better at doing algebra with the trig functions. So, I'm going to turn in the book, see if I can find one. And it says, determine whether the statements are true or false. And I'm going to work one for you. I'm going to work 48. This is 2.2, number 48. And I'm going to work it. Copy this one right out of the book. 2.2, number 48. 2.2, number 48. This is Margaret Lyle's book. She's a lady that wrote a lot of college textbooks. She was a tough professor. Her husband was was Margaret Law and Charles Miller. He was a super easy professor, she was a super tough professor. But they wrote books together. Now, number 48. It says sine of 120 degrees equals sine of 150 minus the sine of 30. And it asks you, is this true or false? And we'll put true or false out here because we'll know. I'm not saying that's true. I'm doing true or what? False. All right. Put a question mark there instead of an equal sign. Because we don't know if it really is equal. I don't like that. All right. Well, all you got to do is look on your unit circle and tell me what the sine of 120 degrees is. What is the sine of 120 degrees?
Square root of 3 over 2.
Sine of 100.
-1.
Square root of 3 over 6.
Sine is square root of 3 over 2. Square is square root of 3 over 2. And then I guess I got to go ahead and put an equal sign, question mark. What's the sine of 150?
1.
What's the sine of 30? So are those equal? No, that's false. That's false. They're not. That's false. They're not. Okay? And that's just a little thing to show you that you can't just subtract what's after the sine and the cosine. It doesn't work that way. All right? But those are good because they force you to do what? Look on your circle. Now, I'm going to show you a little notation. A little notation moment. If you see this, cosine squared of 210 degrees. 210 degrees. What that means, it means this. We just don't like to write all this. That's what it means. Putting a little square there means you do what's inside the parentheses and then you do what? Square. Is everybody okay with that? What it means? And that's one of the little things that's, it just saves us having to write parentheses. We just put the 2 there. If we're cubing it, we put the 3 there. Yes, sir?
Are you supposed to change it to 210 or 120, or is it just?
Oh, my brain was just not, my brain was not working, Mr. Hamway. I wasn't daydreaming at the time. Sometimes I daydream to teach. Okay, what is the cosine of 210, folks? Negative square root of 3 over 2. What's going to happen when you square the negative? It's going to become a positive. You'll get 3/4. All right, and that's how you handle squaring. All right. This, when you see this, means this. All right. Now, the next section, and the section that you will notice, when you look at your assignment, you're going to find out I assign odds all the time. There's one section where I assign every problem. Matter of fact, if they'd have had 50 of these, I would have assigned every one of them. These are like sine of theta equals square root of 3 over 2. And it'll tell you we want the answers from 0 to 360. In other words, we want all the answers that you would get if you go what? All the way around the circle. Okay? So what are they? What does theta equal? What would you have to put in there for theta so that you get square root of 3 over 2 when you took the sine? 1? 60. What else? 120. 120. And this is where the calculator fails you, because the calculator throws out the 60. These are important, because this, when you start solving these, this is what you'll be doing. You'll be looking around the circle for where they are. All right? Now, example something. Example 5. Make that up. Example 6. The secant of theta is equal to negative square root of 2. Folks, secant's hard for me to work with. I don't look for secants. What I do is I change that to cosine of theta is equal to negative 1 over the square root of 2, and then I look for the 1. Never try to look for cotangent or cosecant. Do what? Secant is the reciprocal of cosine, so cosine would have to equal what? The reciprocal of that. Is that good? Everybody follow that? Then look on your circle. Where is that true?
135.
135 is a good answer. What else?
225.
225. See? And because now some people can look for secant. They just look at all the cosines and take the reciprocals in their head. But if you're having trouble with that, realize you need to know where the cosine would equal what? Negative 1 over the square root of 2. All right. The book that all of this comes out of, again, I'm giving a plug here for Women in Mathematics. Margaret Lyle's book. Everything's in here. All the answers are in red. And I assigned it in a little bit different order than what she did in her book. I think 2.2 is a better section to start with, but there is some stuff in 1.2 and 1.3 to build up to it. Okay? And if you go to Canvas, I have the assignments in the Canvas for you where unit circle says assignments, and page is there, the numbers are there, and the answer key is right up here. Okay? And that is the beginning of you using the unit circle.